Hi students, welcome to Alpha's e-learning program mathematics class. Today we are going to discuss about periodicity of trigonometric functions. The concept of periodicity actually we used to discuss even in the other chapters also. That's why particularly I gave here trigonometric functions. So students, let us discuss about what is period of a function. Earlier, while discussing about here graphs of trigonometric functions, we have observed actually when any time if you draw a graph, if the graph is occurring, that means the same shape is occurring for a regular interval, then that regular interval is said to be here period of that particular function. Now observe students, you are aware of this graph, that is f of x is sin x. So fx is a sin x graph. If you take values on x-axis like this, it is a waveform and it is in between -1 and +1. Therefore, if you observe the shape of the curve from 0 to 2 pi, okay, from 0 to 2 pi, the shape of the curve is like this. Again, same shape, it is continuing from 2 pi to 4 pi, like this it is coming, right? And again here from 4 pi to 6 pi, you are observing same kind of shape of the curve. That means here the function actually taking repeated values, understand, repeated values in regular intervals for all x values, that means in its domain. So how it is taking same values, here it is covering all values from -1 to 1. This is -1 here, +1 here, and it covers all values from -1 to 1 in an interval 0 to 2 pi, right? And again in the interval 2 pi to 4 pi, the graph is not going like this. Understand, it is going again in between -1 and 1 only. Understand, again from 4 pi to 6 pi, if you observe, again the function is taking values in between -1 and +1 only. That means same kind of values they are repeating in regular intervals. Then the function is said to be here a periodic function. Now students, what is the period you are observing here? It is, if you consider this is one of the shapes and then 2 pi minus 0, okay, therefore 2 pi is here period of sin x. And again if you take 2 pi to 4 pi, 4 pi minus 2 pi, it is 2 pi, and 6 pi minus 4 pi, that is 2 pi. Therefore sin values, it is, the period is nothing but it is x value. You have to observe this value clearly. Whenever it is given as sin x, then the period is nothing but here 2 pi, okay. Now you can use here period as, suppose the shape you start from 0 to how much here, 4 pi. That means you are taking this curve 1, 2, 3, 4 up to here you are taking. Now students, observe here the same shape, it repeats again 1, 2, if I extend 3 pi, 7 pi and 8 pi, then you will get another one also. That means here same shape fundamentally we are taking as from 0 to here 2 pi, a particular shape, but you can make use of here like this here 3 curves, 4 curves, etc. Then also you can observe here regular intervals. If you consider the period can be here, it is 2 pi, 4 pi, 6 pi, etc. you can get. Now let us observe here in tan function. Observe students, in tan function from -90 to 90, this is the shape of the curve, and pi by 2 to 3 pi by 2 again same shape, and next 3 pi by 2 to 5 pi by 2 also here same shape, right? So here in the gaps of, what is the gap? Pi by 2 minus of minus pi by 2, okay. And whenever you are taking interval a comma b, then the gap value is nothing but, that means length of the interval is known as b minus a. So pi by 2 minus of minus pi by 2, that is pi, and next 3 pi by 2 minus pi by 2, that is again pi. 5 pi by 2 minus 3 pi by 2, that is pi. That means here in regular intervals the tan function it is taking -infinity to here +infinity kind of values. Therefore here the period of tan function we have discussed as how much here? Pi. Okay, in this way students, if you observe only trigonometry functions, the periods we can write obviously. Earlier also while discussing graphs we have done the same thing, and let us observe here what are periods of all these trigonometry functions. So for here sin x and next value cos x, next secant dx, and next value it is cosecant dx. For these four functions clearly we can say the period is nothing but 2 pi. Okay, and the other functions, that is tan x and cot x, we have discussed the period is nothing but here pi, and whereas here it is 2 pi. Okay, and now if you observe mathematically, so far whatever our discussion it is done on the basis of graph. Now mathematically same concept also we can write, and that is f of x plus t, suppose expressed as f of x. This f need not be only trigonometric functions, they can be any kind of functions which can hold good this kind of equality. Then we say the function is periodic and the period is nothing but here t, and that t value must be a positive real number. That is here must, that is positive real number. Moreover, this must hold good for every value of x in the domain of function. No, not it is not here for one or two values this relation should hold good. This relation must hold good for every value in the domain of the function. Then only we can take this value into consideration. So t value, how much students here? It should be always a positive real number. No, not necessarily here it is integer. It could be any real number, but it must be a positive. And next, how we can say the same value here? You can observe here students, suppose tan x, if I take f of x is equal to tan x, then we can say here f of x plus pi equal to tan of x plus pi. And what is tan of x plus pi? Third quadrant, tan value positive, and hence you will get again tan x, which is nothing but what here? F of x. So you got a value x here, and this is x plus pi, and hence what is the period here? It is pi, which is a real number, moreover positive. Therefore period of tan function, mathematically by seeing this also you got here what is the value? Pi. But here we can observe one condition, and that condition is nothing but students, the condition is here not only here pi, understand, for tan function if I write it is f of x plus t, once it is whole good, whenever f of x value, then not only for t it can be even for x plus 2t, understand, it is equal to x plus 3t. You can write here many values in this way. Then we can say once this relation hold good, then these relations also hold good. That implies not only t is the period, but it can be 2t, 3t, 4t, etc. All these also here periods of the same function f of x. Understand students? Now again we are taking here t, but we are telling these many are periods. Here we use here one word, that is nothing but fundamental period. What is fundamental period? That means among all the periods the least value is known as fundamental period. Now these are all here periods of a particular function f of x. Then we say t is nothing but here fundamental period of that particular function. Therefore for these four functions students, the fundamental period is 2 pi, whereas period if I say it can be 4 pi, 6 pi, 8 pi, etc. And again here for tan function the fundamental period is pi, and periods means they can be pi, 2 pi, 3 pi, but they must be here only integer multiples, moreover positive integer multiples. Okay students, so now we have taken here a new word apart from the graphs, that is known as fundamental period. So what is fundamental period? A function can attain more values to satisfy this kind of equation among all those more values, the least positive value is said to be fundamental period of that particular function. So basically in trigonometry we have observed that 6 trigonometric functions, 4 of them are having 2 pi as fundamental period, whereas 2 of them are having pi as fundamental period, right? And now next students, if you observe here about all these conditions and all, now suppose if I take sine square x, understand, if I take f of x is equal to sine square x, then if I write f of x plus 2 pi, undoubtedly the answer is here how much students? It is again the same value it can come. That means it is sine x and whole square. That means you got how much this value? It is again f of x. So immediately you shouldn't decide 2 pi is the fundamental period. It is here, square is there, understand, even par. Therefore I want to take still the least possible value, that is pi. F of x plus pi, that is sine of x plus pi, and here we are having whole square. This is our function and we replaced x by how much here? X plus pi, and thereby this value is actually minus sine x, third quadrant sine value, whole square. That means you got this value as sine square x, and which is nothing but how much here? F of x. Got it? Therefore here to sine square x we can say the period it is pi also apart from 2 pi. Understand? So while discussing about fundamental period, we should be very cautious. So you shouldn't confine whatever the value you got. You have to observe still the lesser possible value also there, possible or not. Okay. Now in the same way, whatever sine square is not at all, you can even use simply sine par 2nx, where n is here an integer. Then here to this function clearly you can say the period is nothing but, that implies fundamental period is nothing but pi. In this way students, whatever even pars any function contains sine par 2nx, cos par 2nx along with tan par 2nx etc., the fundamental period is pi. Okay, and if I take suppose mod values if I write, that is mod of sine x. Understand? If this is our f of x value, now not only even pars, suppose if I take here mod value, okay, if I write here f of x is mod sine x, then let us observe f of course you know about 2 pi, I am taking the lesser possible, that is f of x plus pi. Therefore this is mod of sine of how much actually? X plus pi. But students, what is the value here? That is sine of x plus pi, you know clearly it is minus sine x. Got it? And immediately don't write the value as sine x, because here you don't know about the x value. X can be anything belonging to different quadrants. That's why you have to take this value as same, that is mod sine x. So whenever in any problem, if you got mod of minus a, you should write it as mod a. Unless you know about the value of a, you have to write it as whether plus a or minus a. So we can write in this way, and this is nothing but what actually? F of x. Therefore sin x, cos x, whatever they are taking, maybe period, fundamental period 2 pi, but when it comes with modulus symbol or even pars, then the fundamental period you are observing, those are nothing but pi, even for tan, cot also. Okay students, now students observe here properties of periodic functions. Whatever the properties we are discussing here, those are not only confined to here trigonometric functions, but other functions also, these are here suitable. Observe, suppose a function is periodic with period t. First of all, the function must be periodic. That means f of x plus t equal to f of x. That must hold good. Then only we can discuss about these kind of values. Then the first one is here f of x plus k. That implies, suppose you know students, tan x is periodic with what here? It is periodic with period phi. Then if at all I want here tan x plus, suppose it is 5. Then also here period is how much? Pi itself. No need of here discussing again, drawing graph, etc. Not necessary. Directly you can say as long as there is no change in x, then clearly you can say the period remains the same. Now if at all you have still doubt, let me take here f of x plus k, and this is some g of x. Okay students, let us take this f of x plus k as some new function, that is g of x, and our doubt is whether it is having the same period t or not. Let us check. Now I am taking g of x plus t. The testing of periodicity function is nothing but in the given function f of x or g of x or h of x, just replace x by x plus t. And if you got f of x is f of x plus t, that means the function you say clearly periodic with period t. Now here g of x plus t I am starting for testing of periodicity of g of x. Now let us, that means whenever here x value, here also same x value. Therefore here I am taking x plus t and this is plus k. Okay, but already we have discussed, that means already they said the function is periodic with period t. Therefore this is nothing but how much according as our definition f of x, and this k no change, as it is it will come. Now students, what is this function again? It is g of x. That implies g of x plus t, you got g of x, implies period of gx is what here? T. That gx is nothing but f of x plus k. Therefore this function period also how much here? T itself. In the same way, if you observe these three also, you can say clearly the period is again here nothing but t. So that let us observe here one or two examples. Suppose I want here minus, this is sin x period, understand? And what is the k value here? This k value is minus 1. That means it is of the form minus 1 into sin x. And students, you should here observe the known function. What is the known function? Sin x, and whose period is how much here? 2 pi. Okay, the known function. Now this is multiplied by k, that is minus 1. Then also what is period here? 2 pi. Because when period of fx is t, then period of k times fx also how much? It is t itself. Hence here period of sin x is 2 pi, then period of minus sin x also here 2 pi. So you should concentrate every time whether there is any change in this x value. As long as there is no change in x value, simply you can say the same kind of period. And let us take another example. Suppose it is given as cosecant dx. Understand, what is actually cosecant dx? It is equal to 1 divided by sin x. Got it? This is 1 by sin x. What is sin x period? Actually 2 pi. Then we are not writing cosecant x period is 1 by 2 pi. Okay, so 1 by sin x means it is of the form 1 divided by f of x. So once here cosecant is nothing but 1 by sin, and you know period of sin it is 2 pi, and therefore cosecant period also how much here? It is nothing but 2 pi. It is not here 1 by 2 pi, it is 2 pi only. And this we have observed even from the graph also while drawing cosecant dx graph. Understand students? And now like this here 1 by fx, k times fx, even f of x plus k also. That means if it is sin of x minus 1 if you observe. And what is k here? Minus 1. This k can be negative, positive, or it can be here 0. Whereas here we take negative or positive. So k value can be here negative or positive. Now if you take this is your value sin x minus 1. Now again what about our answer students? It is 2 pi is the period. So period of sin x minus 1 equal to how much? 2 pi. If at all you have any confusion, let me take this g of x is equal to suppose sin of x minus 1. Now what is our observation? We are thinking period is 2 pi. That means if I take g of x plus 2 pi, you should get how much again? G of x. Then you can confirm the period of this g of x is nothing but 2 pi. Okay, so I am taking here the function g of x plus 2 pi. Wherever x is there, students, just replace x by x plus 2 pi. So sine of x plus 2 pi and minus 1. Understand? Here I replaced x value with x plus 2 pi. And what is our original function? It is x minus 1. Therefore, I am writing this as x minus 1 plus 2 pi. Okay, students? Now it is of the form sine 2 pi plus theta. What is sine of 2 pi plus theta? It is again sine theta. Therefore, you got again how much? Sine x minus 1, and which is nothing but what here? F of x. Hence, students, when a function is periodic with period t, you can observe these 4 kinds of values also having here period as t. And another important formula we should observe here, that is not only these 4, actually one more is there, that is the 5th one, that is period of f of ax plus b. So period of f of ax plus b, that means coefficient of x is some real number, positive real number or negative real number, then this is nothing but period of f of x whole divided by how much here? It is mod a. Okay, students, so this is one of the important formulae which we use many times in many kinds of problems. That implies, suppose if I write here sine of 2x minus 3, right? What is period of sine 2x minus 3? Now this is nothing but period of sine x, and divided by how much you have to write here? X coefficient, that is 2. Positive, so I am not putting here mod. And what is period of sine x 2 pi and divided by 2? That means period of sine 2x minus 3 is nothing but how much? Pi. The meaning you have to understand, students, if at all f of x value equal to sine of 2x minus 3 suppose given, understand, then period concept is nothing but wherever x is there, if you replace x by x plus pi, I must get again the same function. To this purpose, wherever x is there in our problem, just replace x by x plus pi. Okay, so sine of 2 into x plus pi, and this is minus 3, right? And now this is sine, existing value is 2x minus 3, so I am writing 2x, and this is minus 3, and this value is here plus 2 pi, right? And now you know, students, 2 pi plus this is of the form theta. So what is sine 2 pi plus theta? It is again sine theta, that is sine 2x minus 3, right? And which is nothing but what actually f of x. That implies whenever period of f of ax plus b if you require, then you should know about period of f of x. Then the answer is period of f of x divided by mod of the value, that means x coefficient, because this is indicating what actually period, and how should be the period of the function? It must be a positive real number, understand? Now to verify, you can make use of just whatever we have done, you can approach in this way. Now suppose, students, we have here tan of, understand, tan of a problem is given as x plus 2x plus 3x plus etc plus nx. Then they will ask about what is the period of this function. So period of this function, you can write this entire value as tan of, here everywhere x is there, so I am taking here x common. Thereby you can obtain here 1 plus 2 plus 3 plus etc plus n and into x. Got it? So in this way I am writing the total function. Hence here what is in the place of a, actually we have this entire value. Of course you know about sum of first n natural numbers, and that value is nothing but how much? Tan of, it is n into n plus 1 divided by 2 and into x, right? And now here you got exactly what form? F of ax plus b. And what is the x coefficient? N into n plus 1 by 2. And what about b value here? It is any real number, and here that value is 0. Therefore, what is the period, students, here? period of given function, and we simplified. This is only just we did simplification part. This is nothing but how much actually? Period of tan x, the original function f of x. Once this is the f of ax plus b, original function, that is period of tan x divided by coefficient of x, and that is nothing but here n into n plus 1 by 2, and moreover it is a positive, so I didn't put here any minus symbol. Then what is the final answer here? The final answer is pi divided by, because tan period is pi, divided by n into n plus 1 divided by 2. Therefore, it is nothing but 2 pi divided by n into n plus 1. Got it, students? So, this is here fundamental period. Whatever answers you are finding here, those are all nothing but fundamental period, and if you multiply again with integers, it will be again the period of the function, but not fundamental period. So like this here, students, we can observe here the example to this one. One more, let us see here. Suppose I am taking cot of 1 minus 5x. What is period of cot of 1 minus 5x? Okay. So period of cot 1 minus 5x means what I have to write? It is equal to period of cot x and divided by here mod of x coefficient, that is minus 5. Okay. So period of cot x divided by mod of minus 5, and what is in the numerator actually period is pi, and what is the denominator? It is 5. So period of cot 1 minus 5x, how much you got here? It is pi by 5. Okay. Now students, let us discuss about period of a constant function. Understand? Suppose if you take a function f of x equal to sine square x plus cos square x, right? And what about here? Domain is all the real numbers, and what is your answer here? It is equal to 1. Got it? Whatever x real number you kept on substitute, but answer always here 1 itself. And now this type of functions are known as here constant functions, and this is here true for all x belonging to R. So whatever x real number you substitute, then the answer is here 1. That implies if you take y equal to f of x, and it is equal to how much you got? 1. And if you take suppose graphically, understand, graphically this is x axis, y axis, origin, you got y equal to 1 for every x. Understand, for all x belongs to R, your y value is 1. That means it is nothing but a line parallel to x axis. So this is the line graph of y equal to 1. And students, observe here while drawing this graph, what is this point exactly? 0, 1. So x you put 0, 0.1, 0.2, 1, 2, 3, etc. As much as all values if you substitute, then always the y value must be here constant. Now to this function, our interest is what about here? Period. Because this is f of x, it is defined function for every real number. Now we want actually what about period of this function? Immediately you may think as sine present, cos present, therefore you may think that maybe the period is pi, or it may be pi by 2 or 2 pi, etc. Like that our view can go. But instead of doing in that way, you have to observe answer you got how much here? Completely constant. It may be 1, it may be minus 1, or it may be 3, any kind of, just it is a constant for each and every value of domain of the function. Now once you got such kind of value, students, you have to observe the graph. It is the same, that means uniform. And if I write here, suppose let us take here integer values 1, 2, 3, 4, 5, etc., minus 1, minus 2, etc. this side. Then between the gap 0, 1, if you find here, you can observe, students, clearly this is 0 to 1, the graph. Again 1 to 2, if you observe what is the graph, same thing. This is 1 to 2 again, same graph. And 2 to 3, if you observe again, same. That means in regular intervals it is taking same value. In an interval of 1 unit it is taking 1. In an interval of again 1 unit it is 1. 2 to 3 again 1. That means obviously the function is a periodic function, no doubt at all in that. Understand? This side also you can observe and here also you can say this one, we can say clearly about all the values. Therefore students, once the function is here, we decided it is periodic function. Now the question is, what about the fundamental period? Understand, fundamental period, about that means the least among all the values. So clearly you got the idea, that is f of x plus t value. How much we got? F of x for all x belonging to here the domain. Here the domain is all the real numbers. Now our interesting question is, what about the fundamental period? What is the fundamental period here? The least among all such values. Here roughly we have taken for 1 unit etc. But period of course need not be integer, positive integer, it can be any positive real number. Therefore, to that purpose, we should observe here, what about here fundamental period. Now, you may think here from these values, this is again the period, suppose half I am using here, you may think here, okay, here again one more line I can take. Understand, again you can separate like this. That means the gap, in the gap of 0.5 or in a gap of 0.1 or 0.001. Like this you can say here, whatever the smallest gap you take or the largest gap you take, then also you can observe the function is taking same kind of value. So in these model problems, that is for constant functions, exactly you cannot decide what is the least positive value, because here between 0 and 1 also you can observe here infinite number of real numbers, and exactly you cannot decide. Moreover, we can't say it is 0 because 0 cannot come under positive values. Positive means 0.00000 like that. We can't say where it can end. Therefore students, whenever any function is a constant function throughout the domain, then we have to say now the function, that means all the real numbers I am taking, then we can say the function, no doubt it is periodic, but here fundamental period is indeterminate. We can't say cannot be defined or in that way. Indeterminate. Indeterminate means you cannot determine. It can be 0.1, 0.5, 0.001 like that. Therefore, fundamental period of a constant function is indeterminate once the x values are defined here, every real number. Then students, you can come here with the case that is nothing but another constant value only I am taking. Suppose it is nothing but sin square x. F of x value is equal to sin square x plus cos to the power of 4x divided by cos square x plus sin to the power of 4x. And in trigonometric ratios and identities, we have observed already about this kind of function. Now to this one, clearly you know this numerator same as denominator. In conditional identities also we have done transformation etc. Many ways we have observed this one. So this is here equal to how much? 1. Moreover, for every real number. Understand? Therefore, this function is here completely a constant function for all x belonging to real number values. Hence, what about here function? It is periodic, but the fundamental period is here indeterminate. Okay students, so whenever you observe sin cos, immediately don't give up. The answer is here 2 pi r pi by 2 etc. But we have to say this is here constant function. Hence the answer is fundamental period is indeterminate. That's why students, you observe this kind of trigonometry values, whatever earlier we have discussed, in this way every time whichever the concept you are discussing, but those values they kept on repeat. Understand?